ask is, yeah, use your phone today. It's not that it's awful. It just does you a little bit of a disservice, right? It's not going to work as well. Now, this is the very, very beginning of your notes. All right, so it begins. You got these all yesterday. If for whatever reason you have lost it, well then, oh wow, that's on you, right? And you better be writing down what you can on a piece of loose leaf paper, please. Now, what all of this comes down to, as we're talking about thermochemistry in this first unit, thermo relating directly to heat, right? So if this is directly related to heat, why can't I move this thing? Why do you think that you need to be right there? Aha, there. Okay, is temperature, right? And temperature is actually kinetic energy. Now, I want you to think back again to either physics if you've taken it, or if you haven't, hey, throw back to science 10 again. What is the difference between kinetic energy versus potential energy? Guys, I tell you, you get to these grade 12 courses, and if you go beyond, you cannot just think, this is just chemistry. We will never talk about any other science. It just doesn't work that way. There is massive overlap between subjects. Mathematics too, of course. So, difference, kinetic versus potential. What do we got? Quick, let's go. Uh-oh. Think back, Sarah, you got it? Hey, nice. That's exactly it. So if kinetic is moving versus potential, I mean, the textbook illustrates it's pretty good. At this point, if I hold my textbook above my foot, it has the potential to do work upon my foot. It has the potential to hurt my foot. This could happen. Right now, is any work being done? No. But if I drop it, then yeah, all of a sudden, in that movement point, we have kinetic energy. Energy of movement, right? When we're about here, in fact, imagine slow-mo, we're moving. We've got both going on, right? Potential to do work and our movement, kinetic energy. Temperature, which messes with people because they don't think of it as movement, is kinetic energy, right? Because when temperature is taken down to a molecular level, we are literally thinking about particles. And particles, way back to grade 8 science, guys, particles are always moving, are they not? They're moving in different ways. They may be moving translationally, where they're simply going side to side, up, down, whichever. They may be vibrating, and they may be rotating. But regardless, this is movement. And this is key. Notice, small vectors representing small amount of movement. We add some heat. Woo! The motion goes up. Always remember, chemistry is inherently logical, right? The things that happen make sense. If I add energy, are things going to move faster? Oh, yeah, they do. Okay, it's logical. Now, therefore, if we change that temperature, right? If we make the temperature go higher, we make the temperature go lower, we're going to end up with either an absorption or a release of energy. Guys, this is important. If a system absorbs energy, we consider this to be positive, okay? And what exactly are we considering to be positive? Well, honestly, the energy itself is categorized as positive. And I see some of you being like, oh yeah, no big deal. No, this is the classic diploma question where I always get people getting it wrong because they're like, this isn't a big deal. It is. You need to know an absorption of energy is positive every time. Vice versa, if energy is released, it is a negative type of energy. That is how we categorize it. All right. So what if I have a system in front of me? Maybe it'll just be a beaker of water. And initially, the water is at 20 degrees Celsius. And then 5 minutes later, I measure it again, and the water is at 23 degrees Celsius. What does that increase in temperature indicate? So say it again. Initially, it's at 20. In 3 minutes, I measure it again. It's at 23 degrees Celsius, an increase in temperature. What would you assume from an energy perspective? What has the system done? Kill it? Yeah, therefore positive or negative. Yeah, nice. Good. Let's keep going. So as this relates to your specific heat capacity, guys, ultimately, every single substance has a different amount of energy that it either absorbs, positive, or releases, negative, whenever it changes by 1 degree Celsius. right? That's where this comes from. Now, in other words then, and this is an important definition, it's up to you how you want to do this, guys. You can see in the notes, I have them kind of bolded, right? Like, here's your definition, know this. Here's your definition, know this. No test of mine, no diploma is ever going to be like, define the following. It's just not going to happen. However, when you hit a question, if you don't understand the definitions, the question gets that much harder. All right, so definitions are extremely important. It's important that you know them specifically and that you're not just kind of think this is what it is, because you're setting yourself up for a difficult reading of and comprehension of a question. Now, specific heat capacity units are really important here. Joules per gram times degrees Celsius. Sometimes you will see a specific heat capacity written as a kilojoule per, and then it's no longer a gram, it'll be a kilogram times degrees Celsius. These brackets are here because that kilojoule is divided by the whole thing. Or sorry, let's do this joule again. Right? It's not divided by just the gram or just the degrees Celsius, it's over both. Just like the demo, those smaller heat capacities heat up faster. For example, alcohol versus water. I want you to check out your data booklets. Flip to the 4th page. So I'm counting this as page 1, 2, okay? So your periodic table is page 1, 2. And then go to this one, page 4. Check out the top. These are super useful. You need to know where these are. There are some specific heat capacities, hence data booklet, guys, information that you need to know. So some heat capacities that will come in handy for questions. So this is inevitably what happens to me. Someone hits a question like, Sakura, there's not enough information in here. I don't have the specific heat capacity. I'm like, yes, you do. Open your data booklet and look for it. So the questions will not just say, for a piece of aluminum with a specific heat capacity, blah, blah, blah. No, it'll expect you to reference this on your own, figure that out, okay? So be aware of that. Guys, this thing looks massive. It is so thin. I picked this up from a garage sale, oh gosh, I don't know, 20 years ago, who knows? And this one's old. This says the Handbook of Chemistry and Physics, 41st edition. Now, if you can see how small the writing is in here, okay? This is from the 1950s. You know that old book smell? It's got that old book smell. Do you see how small it is, though? You know Bibles with that thin, thin paper? That's what this is, okay? This, now, this book, an edition right now, which would be electronic, would be about 5 times this size, right? This is data. This is called, why would we memorize things that we're going to utilize? That's pointless, so let's have a data booklet. From the 50s, imagine it now. Chem 30, this is what you get. You see how little this is? This is like a little grain of sand of all the data that's there. Be aware. Okay, let's keep going. Did everyone find those? Okay, know where they are. You'll be using them. Alrighty, here is your formula. And I want you to look at this thing, and here's a good idea. The back of your data booklet, looking here, there's some lovely blank pieces of paper. One of them is lined, one of them is not. I would highly recommend the habit of writing down all formulas you get there. Now here's the deal. I hinted at this in the last 2 days, but I didn't outright say it, I don't think, to your class. Is there a single formula in here? Like, remember grade 11 and grade 10, you got all the formulas for how to find things? None of them. Guess what that means? Okay, Chem 30, every test and the diploma, you get a blank copy of these that you haven't written in, right? It's one to borrow, which means you need to memorize formulas, okay? So this formula, write it here because this is your working copy. It's the one that's helpful to you when you're working in here, when you're doing your notes, when you're going through questions. But ultimately, you need to get really used to these because you will not get them for a test. In terms of what's what, you should add this into your notes. It's up to you if you add it into your formula or not. Q, and I mentioned this yesterday, is representative heat. That came out as beat. I don't know why. I'm sorry. Do you see this? This is an H, not a B. Don't write beat. Okay, heat. Supposed to be in joules. M, as we talked about Monday, Tuesday, is your mass. Mass for this formula is measured in grams. C is your specific heat capacity. Which joules per gram times degrees Celsius. And of course, our change in temperature in degrees Celsius. Take note, please, guys. Change in temperature is always the final temperature minus the initial. This seems like, yeah, whatever. No, it's a huge deal because this is what's going to make the difference of your energy being correctly positive or correctly negative. If you mess up that final and initial energy, then the correct positive negative will also be messed up. So pay attention to it. Be aware of it. Be careful, please. Now, this is one of those formulas. Yeah, you have to memorize it. I mean, there's different tricks of how you can do this. I don't find it too bad. From a medical perspective, you see, it kind of looks like MCAT, if that catches any of your brains, if you're thinking about medicine or being a doctor or something, right? It's not an A, but it's close. So MCAT is what it is. There's one little memory thing. And because I can, I'll give you another one. Let's see if we can click this up. What is chemistry without a little bit of music? Where's my, oh, there it is. Do, do, do. Come on, work. Yeah, I'm picking you. Yeah, why does it do that? Oh, there. That one. Go. Go. Lucky you. You can dance if you want. I don't mind. Feel free. You're welcome. If you needed something to stick in your brain today, there you go. So ultimately, guys, I mean, really what it comes down to is, yes, please, know this, memorize it, make sure you're aware, okay? All right. Let's continue, because the name of the game, when we get right down to it, is some calculations. So honestly, in Chem 20, I don't know if you remember back, we start the beginning of the course and it's that massive amount of memorization, right? Where we're talking about, we don't really call it stereochemistry, but essentially it's what it is. We're looking at the number of electrons, we're looking at the electron dot diagrams, et cetera, et cetera. And then finally into the second unit with the gas unit, we start to do some calculations. Chem 30, it's like, bam, here we go. Here's the math. And this will continue throughout the entire course, no exception, which means you need to be on top of a few things right from the beginning. Now, the way I approached Chem 30 is a little bit different from Chem 20. Chem 20, and those of you who've had me know this, I am beyond picky about units, about formula, about having absolutely everything written down. And I will take off marks all the way across if you're not following that format, okay? I am still beyond picky about units. Because when it comes down to it, units are what make the numbers make sense. Okay? Yes, there's a lot of math in here, but this is not a math class. This is chemistry, which means knowing what the numbers represent is absolutely essential. Okay? Now, formulas. Formulas get a little more interesting, guys. I think, and this is what I usually see, it's usually about 90% of my students in the class prefer the formula, right? Q equals MC delta T, write it down every time, we're good to go. And then I'll hit a couple that are like, you know what? I can look at the units and I can make them cancel out to end up with my end goal and I don't need a formula. If you can do that, that's great. I have zero issue with that, okay? And what that's called is unit analysis. Now here's the thing with unit analysis. It is not necessarily super hard if fractions make sense to you. Like, I'm not talking like, no, I'm talking like fractions, like whatever. Those are the easiest things ever. If you are pretty good at negative exponents, if you have no problem at all with algebra, if you could do those things in your sleep, then unit analysis will probably work pretty good for you. If you are at all kind of like, I'd probably stick to the formula, I'll be honest with you, okay? So you know where you're at. And I will go through a few questions with unit analysis just to show you how that goes. But let's chat about this one first. Calculate how much energy must be absorbed to heat up 250 grams of water from 14.0 degrees Celsius to 56.5. We are at the beginning. So we're going to go nice and slow with this because some of you haven't done this stuff since first semester last year, or honestly even further, depending, right? So how much energy? At this point, the only variable you know for energy is Q. I haven't introduced anything else, okay? So we know we're looking for Q. How much energy must be absorbed? This is huge. You just got a built-in hint to the question. When I find Q, should it be positive or negative? Yeah, this is big. Because if you calculate it and you get a negative answer, you messed up. Built-in hints are lovely because they let you know if you're on track, if you figured it out properly, so this is good. 250 grams, your brain should instantly go to mass. Got it. Starts here, goes from this, TI, goes to this, TF. If you get this question on a test or on a diploma, this is when you go, thank you, and you cheer and you're happy. It doesn't get any easier than this, guys, okay? This is as easy as it will be. Do you ever get a question like this? Yeah, sure, right? But just be aware. Now, in terms of what comes next, I like writing out my givens. Is writing out your givens essential in Chem 30 to getting a question right? I would say no. But again, you're going to be on a spectrum of people here. There's going to be some people that are looking at this and they can visualize it already and they've got the answer and we're done. And others of you are like, well, I don't know what I got here. I don't know what I've been given. You know where you are. So that means, especially for those of you that are feeling a little uncertain, yes, please, write down what you've got, okay? This will often be one of the best strategies available to you to make sure that you can figure out where you're going with this. I tend to, at this point, just write it down as a delta T, and I won't rewrite my TI and TF. You could, right? But remember, your delta T is always the final temperature minus the initial temperature. So 56.5 degrees Celsius minus 14.0 degrees Celsius. What do we get? 42.5. Okay, there's our delta T. Okay, you know one formula. Today's an easy day. Let's be honest. This is what we're doing. Now, like I said, 95% of you, 90% of you, you better be writing down this formula because you're probably not going to be sure what to do if you don't. Okay, so I would highly recommend, from a unit analysis perspective, start with this. Be prepared for formulas, because if you start just writing numbers and you don't analyze the units properly, I'll still take a mark off. Okay? We're looking for Q. We have M. We have delta T. Help me out here. What's going on here? Nothing in the question has guided us. Go ahead, Sarah. Where'd you find that? Yeah, 4.19 what? Yeah, times degrees Celsius. Get in the habit. It's tough, right? But the more you say it, even for those who, like, if you're not putting up your hand and stuff, say it in your head. So don't just say, oh yeah, okay, the answer is 4.19. Go through the whole thing. It forces your brain to form the patterns to know these things. Like, say it. 4.19 joules per gram times degrees Celsius. Get used to this stuff. Next thing, every single person, I would have this expectation that you would show this. You write in your units and the number. If you just write 250, that means nothing in chemistry. You must have your units, please. Same thing for the specific heat capacity, 4.19 joules. And I'm going to write this slightly different here, right over grams times degrees Celsius. And our last one, our change in temperature, 42.5 degrees Celsius. What if you wanted to do this step right in here? Okay, I don't care. Feel free. That's perfectly logical. Okay, there certainly is some differences to how people analyze a question. All right, now here's what I mean with unit analysis. If you didn't know this formula at all, let's just say you'd never been introduced to Q equals MC delta T, and you still had this question. Our goal is to get to energy, so that means our end goal is to isolate this. That's what we're trying to do. These are all the values we have. We know that. So then you would have to say, self, how do I get this by itself? Well, grams are in the way and degrees Celsius is in the way of that being alone. How do we eliminate them? To get rid of a grams that's divided by, I'm going to have to multiply by grams so that they cancel out. So that's why your brain would go, okay, I need to multiply here. That's how I know that would happen. Imagine you didn't have this. And then grams would cancel out. And then your brain would go, okay, brain, I have degrees Celsius under that joules. That doesn't work. I need joules isolated. I'm looking for energy. So you'd say, okay, brain, how do I get rid of a divide by degrees Celsius? I'm going to multiply by the temperature. Multiply by it, those cancel out. Folks, unit analysis. Okay? Circling what you're looking for to communicate, crossing off as things cancel, recognizing all those are multiplied. If what I just said to you made your brain go, yeah, kinda, keep trying, keep working at it. But if your brain instantly went, yes, got it, think about unit analysis. You might find it really helpful and really useful, and it might limit your memorization. Know what I'm saying? Okay, but like I said, it's usually only 10% that feel confident about it. All right, let's keep going. And answer. Oh, back to the world of chemistry. And again, I am ever so picky about this. We end up with full answer here, 44,518.75 joules. At this point, if that's what you wrote, you just got half a mark. If at this point you wrote this and left off joules, you just got the answer wrong. I don't give you a part mark for that. Too bad. Chem 30. So if that's what you wrote, wrong. Sorry. This would have gotten you part of a mark. How do you get your full mark here? Oh, this makes me happy. Lots of hands up. Katarina, go. Scientific notation helps, but honestly, if you put this as 4.451875 times 10 to the 4, I'll still give you only half a mark. Okay? I like the scientific notation. It's good, but it's not enough. Okay? Yeah, remember those sig digs, folks? Hey, okay. You bet that they apply in Chem 30. This is a course, a science based upon measurement. Things that we measure, look, we measured the temperature, we measured the mass, the specific heat capacity was to 3 digits when it was figured out in the lab as a data point. Yeah, we need sig digs. So for sig digs, what I want you to do is always go back to the question and this is such a big important thing. Not just the question, but whatever you got out of the data booklet. That comes into it too, okay? So sig digs, just say them out loud. How many in 250? Keep going. Uh-oh. Are following zeros after the decimal significant? Yes. Okay. 3, how many? The message is our answer should have, yeah. So guys, when you are doing any sort of multiplying or dividing, we always take the sig digs to be identical as the one with the least number of significant digits. In this case, everything has 3, so our answer will have 3. Yes, I recognize that sometimes when you subtract these, we get different things. That's why I'm saying go to the question, okay? Go to what you've been given in there. So, anyone got it for me? You can express this in a few different ways. I'm fine with that. But what would this answer be with correct units, with correct significant digits? Jeff? That's perfect. Okay. What is another way you could answer this, which would be perfectly acceptable? And honestly, you should know how to do this. Multiple choice. This answer isn't available. What other one could be that would still be correct? Your entire diploma is multiple choice numeric response. Every one of your tests. So be comfortable with this. Kylie? Oh, unfortunately, Kylie, I'll mark you wrong for that one. Okay, so what will happen with that is we need 3 sig digs, which means that we need this to be the third one with this number rounding it up or down. So the 4.45 or 445 will stay consistent, okay? But how else could this be answered? Lucia? Ah, there we go. 44.5 kilojoules is super valid, right? We've had a summer off, and we've had a few months before that potentially where you didn't do a lot of chemistry. Depends. There are 1,000 joules in a kilojoule, right? Kilo, 1,000. So I can take this massive number of joules and divide it by 1,000 to get to this. I do not spend time on conversions in Chem 30. If you are struggling with conversions, you come in for extra help. I will help you forever on your own, okay? We can chat about it. We can go over conversions. I can give you extra work. I'm not reteaching conversions this year. Got it? Okay? Because that is not something that shouldn't be a precursor coming into Chem 30. We will be constantly converting. Questions? I'll say it again. This is as easy as it gets. Okay? Look how straightforward that is. Did you have to manipulate a formula? Did you have to convert anything up here to change stuff? There's nothing fancy here, guys. It's very straightforward. Alrighty? Okay, let's keep going. Worth memorizing, please. Density. If I say memorize it, you should be like, oh, I'm going to put a great big star around this. I'm going to circle it. I'm going to highlight it. Whatever. But you need to know it. Okay? Liquid water. This includes, guys, a dilute solution. And I am specifying that that solution has water as the solvent. Okay? So liquid water, including dilute solutions, this is the density, which essentially all I mean by that, if I've got 500 mils of water or of a dilute solution, I now know the mass of it. The mass of this thing is 500 grams. Hence, the 1 milliliter is equivalent to 1 gram. Similar type thing, if I'm told I've got 32 liters of water, what have I got as a mass? Yeah, kilograms. There we go. 32 kilograms. 1 kilogram is equal, I should probably write it the other way. 1 liter is equivalent to 1 kilogram. For a solution like this, this is what I've been spraying on your hands. Hand sanitizer. Contents, ethanol, 80%. That means there's 20% water here. Does this hold true for this? Why not? Anyone? Just hands. Why does this statement not hold true for this solution? 80% ethanol. Go ahead, Liam. Right? Like there's water in it, but is water the solution, the solvent, I should say? Not at all. Alcohol is a solvent here, guys. It's in a higher quantity. Okay. So now you're going to hit questions, and I'm not repeating this every question. This was my like ding, ding, ding. If I could flashing lights here, I would memorize it, know it. Will it come back in questions? Yeah, it will. Absolutely. You got to catch that. Okay, have a read through this one. Oh, we're good. Okay. Try to figure out what you know here. The good news is the only formula we're using so far is Q equals MC delta T. So you know you're pulling from that. Think about key words. Reading comprehension is still a part of chemistry. Understanding what the question actually says. Tell me what's important about released in reference to energy. Go ahead, Ken. Negative answer for sure. You've been given liters. Chem 20, wasn't this pretty much across the board of volume? We figured our concentrations, we played with it. What else do we know about this? Yes, it's 300 mils. It is also 300, what? Just grams. That gets confusing, and I understand that. So this is that little bit of memorization. So milliliters won't be milligrams, it'll be just grams. That's tough, right? And then same thing, if you got liters, it'll go right to a kilogram. So this is a mass of 300 grams. That's what you've just been told. Yep. Oh, I didn't even look at that. Shavers. Yes. Sorry, Katarina. There, I'm not reading carefully. Yes. Of course, this applies. Okay. Here's where we start. Here's how we end. That does confuse people. Make sure you're on track of that right in your own brains, okay? That where you start is your TI, where you finish is your TF. So you're subtracting them properly to get the correct positive or the correct negative. It's water again, so specific heat capacity is easy. 4.19 joules per gram times degrees Celsius. Change in temperature, TF minus TI. Okay, let's chat. I'm going to show you a trick that you're welcome to do. Okay, first thing, you should have got a negative change in temperature, yes? And this is what's going to make a negative energy. Now, when you look at this, guys, here's your specific heat capacity. That's what you got in your booklets. This is how it's written. Now, you have to make a decision here, and you can go one of two ways. This is in kilograms, this is in joules. Do you see we have a problem? Units have to always work out. They have to cancel out. The whole point of this question, again, is to find Q. Now, does the question specify if your energy is in kilojoules or joules? Do you have to do one or the other? You call it then. You decide. So I'm going to show you a trick. One thing you could do here, if you want, which is fine, is convert this to grams. No problem, because then it will cancel out with this. Do you see that? Times it by 1,000, we have 300,000 grams. Life is good. Here's another thing you can do, which is perfectly valid. Specific heat capacities. If you change the joules to kilojoules, the other thing that changes is the grams into kilograms. From a conversion perspective, this is how it works out. So you can do that. If I now have this as kilograms, do you see how my kilograms will cancel out and I can leave it as 300? You choose. Either method works. One way that I'll do it, I'll get an answer in joules. Great. The other way I'll do it, I'll get an answer in kilojoules. Great. Same thing. Expectation here is have a formula, or if you don't, you show every single unit and how it crosses out. Now, don't get me wrong, you need your units anyway with this, but you might not know how to cross them out, okay? I do it anyway, it's just a habit. So let's go with this method, 300 kilograms, because I sometimes like being lazy. 4.19 kilojoules per kilogram times degrees Celsius. We're going to times by negative 9.4 degrees Celsius, right? Kilogram, kilogram gone, degrees Celsius gone. Answer will be in kilojoules, not in kilograms. Significant digits. Who do I want to bug? Haley, you. How many sig digs will the answer have? Yeah, good. Absolutely. Anyone have that answer for me? Now, if you're putting up your hand, I'm doing kilojoules. So make sure you're giving me a kilojoules. If you know it in joules, that's fine, but don't put up your hand yet, okay? What is our answer here in kilojoules? Let's do this. Let's play with it. What is our answer here in joules? And then we'll convert. Anyone got that? Watch your sig digs. Go ahead, Tristan. Sure. Yeah, you got it. Good. Nicely done. Negative is super important, guys. If you didn't have the negative, you'll lose an instant half mark here, okay? So that really has to be specific. Because it's negative, we know energy is released. Okay, keep looking at this. To convert this to joules from here, we take this number and times it by 1,000. In other words, 1,000 is equivalent to 10 to the 3. True statement? Okay, so I'm just taking 10 to the 3 and timesing it by 10 to the 4. I get negative 1.18 times 10 to the 7. Math and chemistry get along really well. Are either of these answers reasonable? Big time. Okay, either one is great. Okay, questions? Clarifications? How are we doing? So far, so good? Yeah? Yeah, go ahead, Maker. Does anyone need this up still? Sorry, I should ask that. Going once, one twice. Nope, okay. Try this one on your own, please. Here's the deal. Reality is a little different. I know it says board work. Usually at this point, we would stand up and we move around and we go to the boards and we go different places. This is just not where we're at right now. So on your own, try it out. Eventually, we'll start using some little kind of boards at our seats. But at this point, see what you can do. Cord. Now we got it. Good. Okay. So, guys, that you should have gotten if things went well for you, and I'll talk about it in a second here, is we should have gotten 1.48 times 10 to the 3 grams. Yes, no? I'm feeling pretty good. Could you have answered this as kilograms? Yeah, absolutely. So here's the deal, guys. We're going from grams to kilograms, which means there's more grams in a kilogram than there are kilograms in a gram, right? Specifically, there's 1,000. Haley, I know your lap's interesting, but I'm more interesting. Focus here, please. Okay, so imagine then that you've got 1,000 grams in a gram 1,000 grams in a kilogram, then we need to take this thing and divide it by 1,000. Or take this and divide by 10 to the 3, if you will. Either way, that makes it nice and easy, 1.48 kilograms. Now, here's the deal. Number one question that comes up with something like this is like, well, why is my mass ending up negative? And I actually really love that that question comes up. You're right. Does negative mass exist? Right. Well, not in, this gets interesting. If you go into the physics realm when we start to go into other areas, and anyway, that's way past my understanding of things. You almost end up with the ideas of negative mass. But in our simple Chem 30, no negative mass. Okay, this is what we are. So we need this to be kilograms, not kilojoules. We need this to be positive mass, and yet we know that our change in temperature is absolutely negative. I'm not going to go through the question completely, but we've got negative 263 degrees Celsius. Everyone got that, I'm assuming. If that's negative, when I'm doing all my canceling out to figure out what the mass is going to be, right? Q equals MC delta T if you're using the formula. We're trying to isolate mass, so we're going to divide by the C delta T. What you do to one side, you do the other. This cancels out. Here's our formula. Q over C delta T equals M. Classic error. Classic. Watch for stuff like this, guys. Q has to be divided by both of these. Do you see that? So it's almost like thinking these are in brackets when you divide by them. Be careful about that. Common mistake, not one you want to be making in Chem 30 because we're doing stuff like this constantly. So we manipulated the formula to get mass by itself. Q is divided by both of those. Now I'm going to write something down here. We're going to have that we've got 350, I'll make it kilojoules here on top. I've got my C, which for this one is 0.897. I'm going to make it kilojoules per kilogram times degrees Celsius. And my change in temperature, 263 degrees Celsius negative. The way this is done now, I'm going to get a negative Q. Or sorry, I'm going to get a negative mass. Do you see that? What's wrong with this? What's missing here? Kirsten? Yeah, good. This is key. Okay, and this is going to come up again and again when you're going through this unit, when you're going through the worksheet. This is actually negative, guys. So because that is negative, the negatives will cancel out. You will end up with a positive mass. Okay? Kilojoules cancel. Degrees Celsius end up canceling. Kilograms, is what's going to be left. Anytime, no exception, you release energy, that energy is negative, always. Anytime you absorb energy, no exception, that energy is going to be positive, always. Okay, can I move on? All right, let's go. Check out this one. A little bit of a different twist, because will there be twists and questions? Yeah, absolutely. Remember, I don't give you formulas. This is not me being mean in Chem 30. This is the reality of Chem 30, guys. Alberta wide, no formulas. So sometimes you got to figure them out yourself. Read through this. We have now introduced a rate. Cool. We've now introduced time. Oh, not a formula for it, but even though I didn't give you a formula, I gave you a unit. So in turn, if you have those units, you kind of have a formula. Show you what I mean. So if we know rate is equal to 250 joules per a second, then we know rate formularize, here we go, rate, I'm just calling it R. If you called it something else, whatever, is equal to joules. Joules measures energy, does it not? Q. Seconds measures, say it, T. Oh, you just got a formula. R equals Q over T. Is it one you'll ever use again? Oh, probably not. What if you don't want to use a formula, you just want to recognize the units? Okay, sounds good to me. But regardless, there's a lot of information put in here, because here's the deal. This is the rate. This is not the energy associated with this mass of tin. That's just the rate. What we actually know, let's start with that so it doesn't get quite as confusing here, right? This is easy. We know the mass of tin is equal to 5 grams, 5 kilograms. And this time I'll convert it times by 1,000. We have 5,000 grams. Let's use this one this time. We know this is tin. Therefore, I can find the specific heat capacity with no problem. So specific heat capacity of tin of Sn is equal to 0.227 joules per gram times degrees Celsius. These are things that I know. We know that I'm looking for temperature change. Now, ultimately, I've got an initial temperature. This is Ti, right? And really, the whole point of the question is TF. But if I've got TF, I never write this up there very well. If I've got TF and I've got TI, I know if I subtract them, I'll get change in T, correct? So really, it's my goal to find this change in T, knowing that I've got this, so I can later find this. So change in T. Try to find it. Well, great. Change in T is an unknown. At this point, though, it looks like Q is an unknown as well. We don't know what the energy is associated with this yet. How do you find it? Look to here. Can you figure it out? How are you going to get the energy associated with this question? This is not the energy. This is a rate of joules per second. What do? We have a random number of 15 minutes. John, what do you think? Yeah. Nicely done. So John's saying, hey, we're going to rearrange this so we've got Q by itself. Q is the rate times the time. And then this is really important, so good on ya. Seconds is my units in the rate given, which means I cannot leave this as 15. John, walk us through it. How did you get your number of seconds? What did you do to this? Yeah, exactly. Right? Times 60 seconds per a minute. You guys get the idea? Minutes will cancel out. We'll end up with a number of seconds. So if we have our 900 seconds, right, that's our T, and we have our rate of 250 joules per second times 900 seconds, my seconds cancel out. That's beautiful, because now we get joules by itself, which is indeed Q. Rate times time, but time converted to seconds, of course, and we've got Q. And number, what do you got, John? Good. Okay, stop, absorb, think for a second. Any questions? Let's think about the realm of questions, guys. When it comes to any course in high school, we have standard of excellence questions, and we have standard of essentially where it's like, this is where you should be. This is standard of excellence, okay? So in the context of this concept, this unit, this is supposed to be a hard question. So if you're looking at it going, whoa, I have no idea, then these are the questions that pull you over 85, pull you over 90%, all right? That's what these are. Okay. We got everything we need. I'm not looking for Q, I have Q. So we've got Q equals MC delta T. I need to isolate the delta T. Divide by MC, divide by MC, those cancel out. Here's my formula. I want to move you. Come here, you're in the way. Okay. 225,000 joules. You must write units, please. Mass is equal to, here, 5 kilograms. We converted it to grams. 5,000 grams times the specific heat capacity of tin, which, did I write it down anywhere? Yeah, I did. There it is. 0.227 joules per gram times degrees Celsius. Look at those units. Joules are gone. Grams are gone. And I'm going to end up with degrees Celsius on the top, which will be my change in temperature. Don't round yet. You're not finished. So keep on going. Change in temperature, 198.2378 ... degrees Celsius. Did you get a similar answer? Yay, nay? Somewhere yes. If you didn't, you're going to have to look at this more carefully. Remember, most common mistake at this point. You cannot on your calculator, guys, take this number and then go divide by this and then go times by this. You can't do that. You'll get the wrong answer. You need to go this number, brackets, this times this, or things are going to go wrong. The top number is divided by all of the bottom number. Okay? Be careful, please. If you got a different answer, it might be because you number crunched funny. How do you finish this question now? We're still not done. Welcome to Chem 30. What's our last step? We've got change in time, or sorry, change in temperature, right? Initially in the question, we know that the initial temperature is 27.5 degrees Celsius. The change in temperature is 198.23, keeps on going, degrees Celsius. TF is our goal. Looking for this. Can you see where I'm going with this? To get this by itself, algebra, this is subtracted, we're going to add it instead. What you do to one side, you do the other. And lo and behold, done and done. Oh, I can't write with that on here. 2.26 times 10 to the 2 degrees Celsius. There it is. How we doing? Welcome back. I told you, we hit today and let's go. Hit the ground running. And we're flying. Here's the deal, guys. There's one more question at the end here. I want you to try it on your own completely. I'll give you the answer to it. I'll write it up here. And I'm also going to pass out your assignment. There are technically 5 questions on here. Looks a little bit more like 6 of them because there's a part A and a part B to one of them. And that is your homework. And yeah, it's due tomorrow. It's probably half an hour of homework, give or take. But I want you to try. Hi, Skylar. What's up? What's that, sorry? Oh, no, it does impact it, and I always mean to change this, and I didn't. I want it to be 15.0, and I kept on meaning to. I don't think I did in my notes either, did I? No, can you guys change that in your notes? It is one of those adjustments I have been meaning to make, and I keep forgetting to. So, yeah, Skylar, if it was 15, it should be 2 sig digs. You're 100% right. So think of it as 15.0. Thank you for catching that. It's a good catch. Okay. Any other questions? Clarifications? No? Now, this is that last question, guys. Like I said, I will give you the answer to it momentarily. There's like 5 minutes left in class. I want you to see if you can get it. Check your answer, and I'll pass out the homework to you. Answer for this dealio is the specific heat capacity is 0.897 joules per gram times degrees Celsius. Therefore, this thing is aluminum. Work toward it. microphone.